last session we're doing. We already went over 15.2 and 15.3. The reason I do this one at the end is I think this one's a little bit easier than like a normal test. So I think this is like the easiest thing we'll do this semester. Okay. So chapter 15, it's called non-parametric statistics. Does anyone remember what non-parametric meant? It has the word like parameter in it. Anyone remember what a parameter is? When I introduce population, right? Parameters are things that describe populations. So parametric tests need something about the population to be true, right? In particular, parametric tests. These are stuff like the other chapters that we've done before. They involve the population mean, and they really require that assumption. So it required that n was bigger than 30 or the population was normal. There was something about the population that we needed to know. So there was always that assumption question. We always had to write down that n was bigger than 30, population normal. That's what we were doing before. I realized I forgot to take out my notes. Okay. For non-parametric tests, which is what we're dealing with now. Okay, non-parametrics are the opposite of parametric tests. These tests do not require n being bigger than 30 or the population being normal, so it doesn't require this, okay? Okay, so questions for these sections are going to involve things with very small sample sizes, and it's also not going to say anything about the population being normal in the question. These can be done for any sort of question. They're not very useful tests, like they don't give very accurate results, but they can be done for literally any sort of population that we have. Okay. Remember, the non-parametric test, including this thing called the sign test, is only used to test a hypothesis about the median of a population. Okay. Does anyone remember what symbol we used for the median? Yeah, it was a M, right? It looked like this. So instead of the Greek letter mu, we're going to use M. Okay. On the final, you might see this. Okay, that's another symbol that you can use, but it's usually just lowercase m. Very simple to what we've been doing before with hypothesis testing, but we're not going to use the assumption, and we're also using a different symbol. So let me just kind of explain to you how to set up these questions, and then we'll do a little example. Okay, so the variables that we're going to see in this question, okay, first thing we're going to look at is M, which is the median, right? The population median. Okay, we're also going to be given a sample of size n. So n is our sample size. And we're also going to be given alpha because this is hypothesis testing. We always need this significance level. So significance level. Let me just make sure that, okay, good. Okay. The assumptions for this section is going to look a little bit different than what we've done before. We need a small sample size. Right? We're not looking for a big sample size anymore. We want a small sample size. And we need to make sure that there's nothing in the question that says normal distribution. Okay, if it says normal, then we're not doing a parametric test, or we're not doing a non-parametric test. Okay, null and alternate hypotheses are going to look a little bit different. We're still going to have the same symbols, right? HO and H1. Remember, with one sample hypothesis testing, we had mu equaling a number. In this case, it's going to be M equaling a number, since we're talking about the median. H1 is going to look a little bit different. Instead of mu being less than, greater than, or not equal to a number, we're going to have M being less than, or greater than, or not equal to some sort of number. So this is how we set up our alternate and null hypotheses for these types of questions. Okay, confidence level is exactly the same. Anyone remember the formula for the confidence level? Perfect. Confidence level is always the same, no matter what question you're doing. It's 100 times 1 minus alpha for the significance level. Nice job there. Okay. Finally, we're going to find the p-value just like we've done before, but we're going to use a different Minitab command. The Minitab command we're using is the one sample sign test. Okay. I won't go into the reason why it's called the sign test. It kind of has to do with like the signs of like positive or negative of the differences in the numbers. We won't get into that. Minitab does this all for us, so we'll just leave it at that. Okay. If p is less than alpha, do we reject or fail to reject? If p is less than alpha, do we fail to reject or do we reject? Reject, good. And if p is bigger than alpha, we fail to reject. Okay, so these questions are pretty much the same as what we've been doing, except we're using a different symbol. We're using M, and well, we're using a different Minitab test. Everything else is the same. Okay. So what we're going to do, before we get into this, I'm going to show you a little trick on how to know what test to do for each of these. Okay. So basically what I have is I have this chart that we made, gosh, a while back. It was 2 weeks ago. But I added a few more options to this chart. This is the full chart of all the different Minitab commands we can have. On the right-hand side, we have every single test that we've used on Minitab so far, right? We have different conditions for each of these tests to be true, okay? So for example, the test depends on if we have one sample or two samples in the question, right? Two samples, we would use these guys. One sample we would use up here, okay? Within the one sample testing, we have to see if our assumptions are true. So if we have a big sample or the population is normal, we use these tests, which were parametric tests, right? We're now on the sign test where we have non-parametric, where we have small sample size and the sample, or there's no mention of a normal population. So basically what you do is when you get to questions like these, you're going to go through this chart and see which test you're going to use. We'll do a little bit of practice on this, probably on Wednesday. We'll give you a little more practice on which one to use. I think that's the hardest part of this. But let's do an example on how to actually implement the sign test. Okay. So here are the steps to doing this is a one sample hypothesis test, sorry. I meant to cross that out. Okay. First thing you're going to do is you're going to state your assumptions. You need to say that the sample size is too small or that n is less than 30, basically. And you also have to say that there's nothing in the question saying that the population is normal. So nothing like that. Step 2, stating your null and alternate hypotheses, kind of like what we wrote in the first page. Okay. Step 3, calculating your confidence level. Make sure you do that. Minitab, you basically kind of follow the directions, get to that one sample sign test and plug things in. Step 5, decide if you reject or fail to reject. And step 6, write your conclusion. Okay. So we're actually going to do an example. Okay. And we're actually going to create our own data for this example because I'm a little bit bored. Right. So what we're going to do here, let me share my screen real quick, is I have a timer. I also have these really, really badly made puzzles, okay? What we're going to do is we're going to time the amount of time it takes to do these puzzles. But first what we have to do is we have to come up with an estimate, okay? How long in, I don't know, minutes do you think it would take to do a 48-piece puzzle? Any guesses? I think it's gonna take longer than 2 minutes. No, but I actually kind of was thinking that at the beginning. Yeah. 5 minutes, all right. Anyone else? Okay, let's do 5 minutes, okay? Let's just say we think the median is going to be 5 minutes. And I'm actually gonna calculate that in seconds, so we're not like kind of confused here. Let's do 5 minutes to seconds, which is 300 seconds. Okay. So we think that the median is going to be 300 seconds. Okay. I think it's going to take a little longer. Okay, so I'm a little suspicious. I'm going to say the median is bigger than 300. So what we've done, we actually created our null and alternate hypotheses. H0 is our null hypothesis, what Alexa said. The mean is about, or the median is about 300. I think the alternate hypothesis that the mean is bigger than this. Okay. Let's put it to the test. I'll have groups of 2 or 3, and I will give you the chance to pick your puzzle. These puzzles are very badly made, so have fun with this. You want to do a group of 3? All right, so let me take a look at our null and alternate hypotheses. The reason I didn't ask you to write these down yet is maybe we have to adjust it a little bit. Maybe 300 was a little bit overshooting. And to get a little bit better results, I'm going to change. Do you want to make our null hypothesis? I don't know, 400. I know it's cheating a little bit. Maybe 450. Yeah, I know we're kind of cheating a bit, but let's make the numbers. Okay. So if we go and do this, let's talk about the assumptions and stating the null and hypotheses after we do the p-value. The reason I'm doing this is so I don't have to switch back and forth. Okay, so I thought it might be a little bit bigger than the null hypothesis, okay? The way you would go about doing this on Minitab, okay? You will go into C1, and I promise you, you won't have to actually do this on like the final exam or anything. This is how you would go about it. You would type in 578, 403, and 405, okay? We have 3 data values. I'm gonna go to stat, non-parametrics, what? Oh my goodness. And 1 sample sign. Okay, that went away. Under variables, you're going to click C1. We'll calculate the confidence level after this, but it ended up being a 95. I'm going to click test median. The median is what's in the hypothesis test, so 450 is what we're looking for. And under alternative, I'm just going to write what I said in the alternative hypothesis, which was greater. Okay. Once I hit OK, it's going to give me a p-value, which ended up being 0.875. Okay, let's go back and formally do this question, and then we'll see if we come to a nice conclusion or not, which means I have to go and get myself set up. Okay, so here's our example. We wanted to find the time in seconds it took to put together this puzzle. We did this by collecting a bunch of data values, right? Now, our data values, unfortunately, aren't very much, but it looks like we had 578. We also had 403, and we had 405. Okay, so these were our 3 data values. Okay. What did that mean n was? N was equal to 3, perfect, because there's 3 values. Okay. Step 1, we're going to check our assumptions. We have to check for 2 things for non-parametric tests. Is n bigger than 30? No, right? N is less than 30, which is actually a good thing for this section, right? We don't want a big sample size. We want something really small. The second thing we have to do is we need to go up to the situation. Is there anything about a normal population going on here? Yeah, no normal population, right? So there's nothing saying normal. Okay, because these 2 things are true, we can go on, and we also know that we can use the 1 sample sign test for this. Okay, Null and alternate hypotheses, we kind of already wrote them up on the board. Let's just pretend that Alexis said we thought the median was 450. And well, I said, no, I think it might be a little bit bigger and bigger than 450. Okay. Step 3, finding the significance level. Significance level was 0.05. Can someone remind me of that confidence level again? 95% and good. It was 95%, but to find it, we would plug it into the formula. 100 times 1 minus 0.05. I like to do the subtraction first, 0.95. And multiplying that by 100, we get 95% as our confidence level. Okay, so that's how I knew I had to type in 95 in the Minitab. Okay. Flipping over, we went to Minitab. We showed how we would click to get this pop-up window. We would type in C1, 95. Our test median is equal to that, and we have our alternative hypothesis. The p-value for this question ended up being, I forgot to write it down. Let's see what it was. It ended up being 0.875. Okay, 0.875. Okay, same thing for steps 5 and 6. First, we need to decide if we reject or fail to reject. And we do this by comparing p to which value? Alpha, perfect. P is 0.875 and alpha was 0.05. Which one was bigger, P or alpha? P, good. So do we reject or fail to reject? Fail, perfect. Now remember, in step 6, our conclusion consists of 2 parts of a sentence. The first part says we conclude or not enough evidence. Which one do we say here? Good, there is not enough evidence to say. And what do we always end with? The alternate hypothesis. In this case, we're not talking about mu anymore, we're talking about m. M is bigger than 450. Okay. Any questions on this example here? Okay. Now we have 2